here with Jayson Bethurem, Vice President of Business Development at Rapid Silicon. Welcome.
Thank you, thanks for having me, great to be here.
So why are FPGAs attractive for AI applications?
That's a great question. As we've seen over the evolution of time here with the evolution of AI algorithms, the deployment of them has been in scalar sequential processors like your desktop PC where you execute one instruction at a time over and over again. That was what was offered initially. What we saw over time is that people figured out how to use other types of technologies to do more simultaneous multiple instruction in multiple data type instantiations where you can do multiple executions on one piece of data. And what that got deployed in, you saw a lot in the beginning, was GPUs and things like that. But what people then saw, other technologies that could deploy this technology even better, were FPGAs, because of the nature of the FPGA and the architecture of the FPGAs allows these networking algorithms to be done in parallel fashion. Therefore, you can execute them much faster than a sequential processor. So FPGAs, because of their technology and having a lot of signal compute elements and internal memory, can hold the data and execute the data simultaneously without any outside interference of an application processor trying to execute its own other memory that it's accessing from other threads. So isolating that and having the resources to do it all in one spot is a reason why FPGAs are a great fit for AI embedded applications.
And can you tell us about some of the applications for FPGAs in AI?
Yeah, great. Well, we definitely see more of a migration. We saw a lot of the AI applications be done in the data center for classification and in other inference types of applications. But when it's coming down to edge applications, whether it's in cars, industrial manufacturing, or even in our general world we live in, we see applications such as, we still see classification, but we see anomaly and error detection, fault detection. We're even seeing it in signal processing applications where you're looking for anomalies in the data, right? Just the amount of places that AI is being deployed today is just really, really growing, and it's becoming more pervasive, and the requirements on these applications have that same kind of performance you get in a modern system, but at a lower power and a lower cost point. So these applications, every day, we see them grow and grow and grow. It's pretty impressive, so.
And so what are the requirements for AI edge applications?
Yeah, that's what I was just kind of getting into, is that realistically, when you're deploying, you can't deploy a data center type application or function into an embedded edge product, like an industrial vision camera or something like that, that's doing a defect detection through an assembly line of a product being manufactured, right? You can't put that very expensive part into this small application. Or in a surveillance camera that is doing some kind of intelligence on crowd control or issue anomaly and issue detection there as well. So the requirements we're seeing are being shifting and focused to an edge type application. And all of these AI applications have to be run in hardware at some point. So the requirements of this hardware is that you must have the signal compute capability, as well as meeting a cost requirement as well as a power requirement, because most of these applications could even be battery powered or in an environment where you don't have a lot of power available to you. So whether it's power over Ethernet or USB powered or something like that. So those are some of the general requirements we see that we're trying to build solutions and products for.
And why do you think it's taken so long for FPGAs to be used in AI edge applications?
That is the golden question. As I said in the beginning, there has been an evolution. We've gone from the high-level CPUs down to GPUs, and now it's down to FPGAs. Realistically, AI and FPGAs have a very synergistic relationship due to the hardware features I mentioned, the ability to do parallel processing, the embedded memory. But that also involves complexity, right? Like I said, there's this very good synergistic relationship between the two. The problem is, it requires a software and hardware element. And when most people try to deploy AI solutions in hardware, they come at it from a hardware-centric approach first. I'm going to develop the hardware first to build my AI accelerator, and then maybe I'll put on top of that, the software that controls it, that passes the data, that manages the data through the system, and then of course reacts to the analysis of the AI algorithm, right? So that was the hard part. Everybody came at it with a hardware-centric idea first. And some of the initial deployments in FPGAs, the hardware piece is very hard to figure out, and they built just models of things, static models that people would run their AI algorithms on top of, which actually shows incredible benefits in performance, but still isn't the most efficient and optimal solution. And what we're doing at Rapid Silicon here is that we're taking it from a software-centric approach, which is where most of the AI models are developed and built in the first place, and giving customers a flow to go from that software into hardware, and we're optimizing that hardware specifically for that algorithm, which is kind of a novel approach. It is something that we are working on. It's also an approach that's been heavily invested in from open source communities and companies like Google, and we're adopting that and optimizing that towards our architecture. So why it's taken so long is it's just taken a while for people to figure out how to not come in from a purely hardware approach or simply a software approach, but having the expertise and the know-how to utilize the architecture at your hand and put a packaged solution together. So I think it's just some of the complexities in using FPGAs is why it's taken so long, but now that we've gotten here, the interest level is very high for doing these kinds of applications in this space. We really have the unique product, the only really unique product that can do this at this level of performance and cost and power point.
So how is Rapid Silicon answering these challenges?
Yeah, so I started to answer that question a little bit too. Yeah, we have started working on leveraging some of the open source pieces that I've talked about, the elements in the ecosystem. Like what Google's doing with their CFU IP playground, we are leveraging that and building on top of that novel models that can be implemented and optimized into our hardware that can really give the performance expectations that customers have to meet those expectations. And like I said, we are also developing that architecture specifically to do AI algorithms. Like I said, we are embedding in a lot of memory in the system. Every AI algorithm needs a lot of memory to handle the batch size of the data that's coming in. Then you of course need to have AI optimized hardware, and we are building signal compute blocks in here in our devices specifically to handle those kinds of workloads. So it's really a combination of the hardware and the software tool flows. Everything we're doing has an AI focus in mind in building this architecture.
And so can you tell us, sorry.
So that's really how we're going about trying to solve this problem for industrial IoT customers and so on and so forth, yeah.
And can you tell us a little bit more about Rapid Silicon?
Yeah, Rapid Silicon, on the onset we are a new company. We are really built on a very veteran crew of people who've been in the FPGA industry for a very long time. And that includes companies like Xilinx, where I came in before this, and Intel Altera, which many of my colleagues come from as well. So we've really been in business about 2 years. We've come in a focus to build, really a laser focus to build embedded edge application products. Whereas you can see from our previous companies, there's been a focus to go service those data center type applications and AI in the cloud type applications, which is a great market and a great business to be in, but it leaves a void for everybody who's trying to deploy these types of AI edge applications into edge embedded products. And so again, like you can't put that data center product into an edge application. The power, the cost requirements, they won't be aligned. So Rapid Silicon, when it got started about 2 years ago, was really with that in mind and focus. How do we service the embedded edge? How do we provide solutions for our customers? And how do we provide technology that works in these types of applications? And that's exactly what we are and what we're doing.
Right. So. Well, thank you for joining us in Austin today.
Excellent.
Thank you.
It's great talking
Jayson.
to you. Thank you.